In this video, I will introduce the LIGO language created by LIGO. So LIGO is composed of 3 teams. LIGO composed of 10 developers that work on the language and its compiler. Serokel is a team of developers who work on tools like a LSP, debugger, and TryLIGO IDE. And ECAD is a company that takes care of the website and documentation. The idea of LIGO was based on a simple observation that the Michelson language is not very suitable for application developers. So a higher level language was needed to develop smart contracts on Tezos. And the goal was to focus on reducing the barrier of entry by minimizing surprises and minimizing the risk of bugs in the language. And the solution that was chosen is to create a dedicated high-level language that compiles to Michelson. And the particularity of LIGO is that it has 4 different syntaxes that cater to different developers' tastes. And another aspect the LIGO teams are preparing is the certified compilation and the support for static analysis. So beyond the language itself that we will introduce, LIGO also has support for modules for big projects and code sharing. It has an online IDE called TryLIGO, so that you can start testing within a few minutes. It supports IDEs in different ways with an LSP extension for VS Code and with an MX plugin. It has support for unit testing integrated into the language, and has an active community available on Discord, Telegram, and Slack. And you can follow this link to join it. And LIGO is an open project under MIT license, so it's open to contributors, and don't hesitate to contribute if you would like to. So let's look at the different features supported by LIGO. So first, of course, every Michelson type operation and API, from the int type to test to maps and even to tickets, is supported by LIGO. You can manipulate arithmetic and Boolean expressions without any surprises. You can create constants, variables, tuples, and records. You can also create user-defined types, type aliases, composite types, and LIGO supports advanced type inference. It supports pattern matching, including nested patterns, and functions closures, including terminal recursive functions. It also supports functional or imperative iterations on lists, maps, and sets. Finally, it has modules, the possibility to include other contracts, inlining to optimize performances, and inclusion of Michelson code. So the same core language supports 4 different syntaxes. CamelLIGO, which is inspired by the Camel language, PascalLIGO inspired by Camel, ReasonLIGO by ReasonML, and GSLIGO, which is inspired by JavaScript. And there are some plans for a Python LIGO version in the future, which is based on Python. So every syntax is as close as possible to the language it is inspired from. And every LIGO feature is available from each of the syntaxes. So there is only one core, one compiler, and one type system. But each syntax keeps its own specific advantages. At the heart of LIGO, there is a minimalist language that each of these 4 syntaxes are converted to before compiling to Michelson. An example of smart contract in 2 flavors, one in CamelLIGO and the second in PascalLIGO. So you can see the same structure, but a very different syntax. As we said, LIGO offers an online IDE. So here's a look at what this IDE looks like. You can compile, test, and deploy contracts directly from the IDE. So without installing anything, you can quickly test some contracts and play with the language. LIGO also comes with command line tools that you can install in your own computer. And there are 2 options for installing these tools. You can use a Docker container, or you can use binaries for Ubuntu and Debian. LIGO has continuous integration with immediate publication of the new versions of the tools. It has an LSP extension for VS Code and an Emacs plugin. And the command line interface makes it possible to compile a smart contract to Michelson, to compile the value of the storage and parameters to Michelson, to transpile a contract into another syntax, and to test the execution of your contract. And the deployment itself is simply done through a Tezos client with the Octez suite. So for testing smart contracts, since LIGO is strongly typed, its type system means that compiling is already a way of testing to some degree. But you can also create your own unit tests directly in LIGO, or you can develop integration tests with libraries like Taquito.